everybody again. Today we have a particularly exciting talk by Professor Hong-Linh Truong from University, who is in software systems and thinking hard on how would that angle benefit machine learning or vice versa. So, yeah.
Right. Thank you. Thank you very much. So good morning, everyone. So actually, I have been here for 1 year, but I think this is a great opportunity for me to discuss with many people in machine learning domain, because for us, actually, machine learning application and system become very important because we are working on software system, distributed computing. So we need to solve for a new kind of application and system, and nowadays people are working a lot on machine learning. So it's very important. So that said that I'm not a machine learning guy, so don't challenge me, about something inside machine learning model or whatever, because then it's very difficult for me. So I want to discuss about quantitative analysis as a way that we can use to optimize machine learning system. So this thing bring up some of the old idea, but also the current focus of my research team in the way of how to optimize machine learning system from runtime viewpoint mainly. So the talk today, as I understand, is as a seminar. So actually, it includes some work in progress. Some of my talks I have not really published it, but also some initial results from collaboration with some other people. And I want to show especially some initial results from 2 master theses. One is done last year, one is currently submitted from Anto, where we work with companies surrounding here, try to apply the concept of qualitative analysis, the idea for the companies. Yeah, so as I said, work in progress, so a lot of ideas, just here and there, and maybe it's good for us to discuss and as a way to collaborate. So I will discuss about quantitative analysis and then principle of elasticity, the thing that I have worked in many years in service computing and cloud computing and so on, and big data. Then I will discuss about quantity of analysis aware optimization for machine learning. What exactly like that from our viewpoint? We give you some initial results and then a couple of bit items for the next step. And I think the bit item is where we really can discuss to see if we are able to collaborate in these topics. So the thing is, I think the research focus is the question is how to optimize end-to-end machine learning. I want to stress about end-to-end here because I know that many people working in machine learning make assumption that the data available, then you focus a lot on machine learning model, algorithm, do the training. For me, end-to-end, it means I would like to look, as a whole system. If you think about like production, machine learning production, the user click the button, you generate the data, you extract the feature, you put it somewhere, then you start, to do like model serving or whatever. It's a whole end-to-end. So it's very important because when we look at the end-to-end, I examine the issue of system, right? For example, a very simple thing, but might be difficult for people in machine learning is how to manage the resources and the data. And now that we are not yet running a lot of machine in cloud, in supercenter or CPU, but also the edge with a lot of small devices and so on. And you have the data, for example, generated by IoT device, by drone and something like that, on the fly. That's the thing we do. Very difficult. But actually making the machine learning model serving, under the kind of like machine learning as a service, robust, resilient, right, and reliable, extremely difficult. Okay. So we want to focus on the optimization that I know that the machine learning community focus a lot on, for example, machine learning model benchmark. There's a benchmark short paper with 20, 30 authors. Then there are also the website about machine learning benchmark and so on and so forth. Or hyper-parameter optimization. I want to think more about, can we have like end-to-end runtime management? Can we have this kind of very dynamic machine learning model serving, right? We develop a lot of machine learning model. We deploy into the flavor. We serve for different customers. How can we manage in a dynamic way? And what about machine learning experiment? We know that in order to run, to optimize hyperparameter, you run huge number of experiments in different variation of hardware, software configuration, right? How can you liberate them in order to optimize the runtime? So this is the focus. So I want to use a very high-level abstraction way to discuss about the qualitative analysis. So the principle we have big data or machine learning system can be very complicated, very complex. The principle that if you have this, you will utilize different big data processes and machine learning models. You might use 1, 2, 3, or you might different things and combine them together. Then you will execute in a machine, like hardware, computing infrastructure, like cloud, edge. Yeah. So now we will combine edge and cloud into a continuum. In the future, we will use quantum computing, whatever. Then, now you have big data in. The big data here, it doesn't mean that it's static data. It doesn't mean that the data is rest, but it can be data in motion, right? The data come from drone or whatever on the fly or from the car. Then you have the results. It's very high-level abstraction, but every component here can be very big, very complex. And the thing from the qualitative analysis viewpoint, we have actually a lot of hard questions. Right? I give you one example, right? Is the data good enough? If the data is not good enough, what are you going to do? For example, continue to get the data and do the machine learning analysis or stop, get rid of the data. We know this is a huge big problem, right? So if you have, and to run in the computing infrastructure, you ask a lot of other questions. What about execution time, training time? What about time failure constraints? So we run the machine learning in the computing, it returns the results very good, but it's too late, right? 5 minutes, 5 seconds is too late. And in terms of system, this means it's a failure. So everything is correct. You are able to detect the object. You are able to return everything highly accurate, but too late. 2 seconds is too late. Then from the end-to-end viewpoint, from the machine learning production viewpoint, it's a failure. It's a failure because it doesn't actually produce the concept of reliable service, where you have to guarantee the time as well. What about the results? Right? If the results is accurate or robust enough so that you can continue to forward the results to the next phase, or store it, or stop. So if the result is not good enough, you go back, right? So like we say, like for example, in medical, long time before we discuss about machine learning, we work a lot on workflow to simulate, for example, the pulse of the patient or whatever. We simulate like a couple of days, and then we look at the pulse, we see it's not good enough. Do we continue or we stop? It's a huge number of problem here. So this kind of quantitative analysis is high-level abstraction, but if you multiply for multiple phases, the complexity of different components here, you can put huge number of questions, So that's why we talk about quantitative analysis is in scale, it's really very, very challenging to manage across multiple data analysis context here. You can say data analysis context on machine learning, it's the same. For example, you need to interact with different data processing machine framework, right? Machine learning framework. You have to interact with different input and output data source, different system service, because we are not going just to run the model, right? For example, we need to think about how to do the provisioning, monitoring, and control as well. And if you do in the real machine learning system, you see there are a lot of other services you need to master, Can you, like what we discussed before, can you write few line code, then you have hundreds containers where you can run a virtual machine. That's easy, right? But if you don't know, then it's difficult. But for us, for people who work in the system, it's so much easy. They write only few line code, they click the button, then Kubernetes run and deploy hundreds machines for you. So this actually huge number of problems here, right? So we can think about qualitative analysis as a composition of multi-dimensional data, quality, performance, cost, whatever, important for your machine learning. And thinking this way, it means that you can establish quality of analysis as a contract that to make sure that you deliver the reliable service, to guarantee quantity of analysis. So this is a high-level abstraction in terms of quantity of analysis. And the reason why we have quantity of analysis is because the nature of elasticity. So the principle of elasticity is that, for example, you have a service, and if you have a stress or some kind of external force or whatever, then you need to stretch it, change the form, and then if everything, the force disappears, everything should go back to the normal form. So thinking about quantity of analysis from the very first viewpoint that we, for example, before we submit a paper, we have to run a lot of, experiment night and day, even give $1,000, whatever, because tomorrow is a deadline. You work for 6 months, you don't want to say, oh, $1,000 is too much, and wait for next year, right? So you're ready to spend a lot of money, right? But if you have time, you would not say, oh, $1,000 is too much for the university. So this is the very nature of the principle of elasticity, like demands. So the customer has a different demand at different time depending on the purpose, right? Running experiment, running for the production is very different. Even for production, that sometimes you have a very different kind of requirement, like I want very fast, accuracy is medium, it's okay. Sometimes you say, take your time and run this, as much as you can, but I want to have like 100% accuracy. It's a very different nature. So this is demand elasticity, right? And then you can have like output elasticity, the results can be different, right? Different form of results, different accuracy, whatever, depends on technique. And one thing we also have to look is the input elasticity. The thing we always make assumption that, okay, we have big data, right? We make big data, we say, I have a lot of data going to my machine learning system, for example, but what does it mean big, The thing can be changed. So typical thing we see, like for example, if we monitor very large scale network, like I have worked with people like monitor like with 5 million sensors. And what is the thing of 5 million sensors? Actually, the sensor has been predefined. So every 5 minutes, if you send the data, so you see that there are periods of 5 minutes, there are no data at all, right? And then after 5 minutes, sorry, 5 million sensors start to send the data. So you see that the data is also never be the same. So how do you deal with this kind of situation? So this input elasticity. But then the quantities are very different. So you know that you work with the machine learning, even the different resources have different quality, and you have different model also have different quality. So I give you another view from the principle of elasticity and how we combine quantity of analysis and elasticity together. So it's very high level view, but this is the thing that we do all the day, right? So if I have data, then I need to do the analysis in order to produce the results. I will have some sort of analysis process, and then inside I have a task. For machine learning is the same, right? Analysis process can be a machine learning model, right? And the task can be some parts of the model, things like it. So if you do more data, usually we just automatically add more and more machine, because probably we don't need to change the process and the task and so on, right? And then the situation, you have a new type of data, right? Sometimes with the new type of data, your analysis cannot be able to process. So you need to change the analysis by maybe having a different process and then different tasks, and so on and so forth. Right. So this is a typical thing we are doing as well. But most of the thing we are doing here is in a manual way. But then the tricky part is, if you think about the results you deliver from the analysis is not just the accuracy, right, but also the time, right, also the money and many things. And what if the results is not satisfied in terms of quantity of analysis? So if the data is not highly accurate, where do you want to change? Because sometimes you change the machine, you maybe do faster, better, right? Sometimes you change the data, or sometimes you change the algorithm. Actually, there are no, there are no unique way to do it. Because it doesn't, people say, yeah, let's change, the algorithm. It doesn't mean that if you take a better algorithm, you will have better results. because maybe the data is really bad. And another way around, who are able to establish this kind of relationship? I think it's a very tricky point, right? When we work together, we need to understand the data, the algorithm, machine, and many things like this, like that. And of course, part of my job is how can I provide tools, right, to help people to do this? Because there's no way for me also to able to detect everything, right? So this is the very tricky point. So this is put into the question that if we want to support quality of analysis as a way to optimize machine learning system for example, there's many points, right, we can do. And it doesn't mean that we have to focus on everything here, but maybe some people will focus on dealing quality of analysis in terms of task and process. Some people dealing with data, some people dealing with the machine, right? And in the software system for machine learning, how can we combine them together? So the principle that if we try to apply elasticity engineering, we need to think about design and program elastic software system. Then you must have automatic deployment and configuration. And you must have monitoring analysis. And the tricky part is how to coordinate elasticity across different phases, different components, especially when you run machine learning in a very large scale or federated machine learning. How do you coordinate this? Because if we say the quality of one place is really bad, how it's influencing to the other one, and how can you coordinate this? So how can we apply this approach for machine learning system? I write out here a couple of points. I think the first thing that if we think this is the right way, we should try to think quality of analysis as a contract. So maybe when you start to say, this is my model, right? This is my model. And if you want to guarantee my model work, this is the contract related to my model. The contract has some information related to, for example, the quality of result, the input, the money, or whatever. Right? So it means from the programming languages, from service people, we need to formalize this kind of thing and have a better way to describe this. Right? And then when you have this kind of contract, it means like if you deploy the model, or you want to do this, testing or whatever, the system have to guarantee this. It means if the system doesn't support this, you have to question, can I get, how much money do I have to spend? What is the accuracy? Can you detect, if the data has some problem or whatever based on the contract? Right? And the contract can be changed at runtime by even people or intelligent software. And that's why we also use machine learning in order to understand the quantitative analysis as well. Yeah. So I come up with initial idea, still idea. So we're thinking about like if we have quantitative analysis from machine learning, we categorize into resource, quality, and cost. The resource, I think it's important to think computing and data. This is the thing we learned a lot in cloud computing. Now the model, it becomes very important in machine learning. So I think the resource could be also model as well. So this is the extra thing that I bring into this picture. And then if you talk about quality, of course we will have a lot of typical quality dimension like performance, reliability, and so on. And data quality become very important. Right? But then you also have the quality related to the model, right? So how can we capture the quality related to model where we have to learn a lot from machine learning people with what is the accuracy, the loss, and F1, and something like this. So this is just initial work because some metrics I understand very well from the system and something like this. Some metrics I know from the definition, I know, it's work, but dive deep into this is a great collaboration is needed, But if we are able to have this kind of dimension, then we can think about what is the elasticity and quality of analysis, right? Then the question is next is, what are the elastic objects in machine learning system? What can be changed at runtime? So if you have a model, you say nothing changed, then we cannot do it. The only one thing we can change is machine, right, and data. But if you have a model with a certain parameter, right, that you say can change at runtime, then this can become elastic object, right? The thing in the elastic system that you have only a few types of elastic object combined with non-elastic object, you can have also very great, very good elastic system. So this is the principle. We need to determine this. And what is the primitive operation that we can use in order to change the object in your machine learning, right? So for example, can we change the resource? Can we change the model? Can we change the input, right? And the next step, that how can we incorporate this kind of thing into a programming feature? It means that when we program it, we need to have some feature to specify it. That may be related to what we discussed about, whether data as cost and the concept machine learning, right? And then runtime control and something like that. So this is the second step. And then the resource have to be elastic. This is easy to understand because this is from the software, distributed computing. Nowadays, people combine IoT, edge, and the cloud together. In my lab, I have even this kind of USB running with TPUs, right? So think about like this. How can we have this kind of thing combined together? And if we establish this into a virtual computing resource, then we can bring up in the concept that I have been developed since a couple of years, but still, have not published this, what I call application-specific resource ensemble. The way that you can get, very dynamic resource across edge and cloud and provide it for the application, for some more machine learning. Now, the elastic object in machine learning workflow, as we said, it can be many things, right? So how do we look from the structure? So for me, the end-to-end machine learning workflow is kind of meta workflow or meta pipeline. And inside you have individual workflow or pipelines, right? And then, for example, individual workflow and pipeline could be data collection, pre-processing, training, model serving. And inside each pipeline here can be very complex pipeline and workflow with a lot of services. And in practice, we see that the whole end-to-end here is never follow the same software stack, right? So for example, we use a lot of cloud services and big data tools to manage the data like S3, Hadoop, or whatever. Then we start to use some other framework for training and for machine learning. And coupling them also very tricky, right? So for example, if you use Hadoop and something like this, you have a tendency to use, for example, Spark machine learning library or whatever. Then you have a tendency to run it, in a typical computing system suitable for Spark and something like this. So in terms of software engineering, in terms of software development, it's very difficult. But then if we apply for the quality of analysis and elasticity, how can we coordinate different phases? Right? How can? So at the moment, there are some tools allow you to run multiple phases, like ML flow or Kubeflow from Google or whatever, there, right? They also just developed a few years ago. Last time I was in Google, I think like 2 or 3 years ago, just initial. But now it's run very well. But still, they are just allow you to run multiple phases, but are not really dealing with the cross-quality issue yet. So how can we improve this situation? And then, can we apply the principle of to monitor flow in order to apply primitive operations? So I give you an abstraction that what we deal with. So in terms of, if we look into the data and the machine learning, the big data, we consider it as a data, then you go into one flow, right? A data analysis flow. Then you produce the results, what I call data asset, and then it goes into the next thing, right? So if I replay this one by machine learning flow or workflow, whatever, the concept is the same. Right? And then it can be run in different places. Now, if you think in this way, the tricky part for us is when the data go into the flow, are we able to determine certain quality or whatever, right? So that we can start to give input to the data analysis flow. And then if you go to the next, the next thing you have access, then if you're able to monitor this, right? You can adjust quality of whatever, then you go to the next thing here. And if you use this model, you see that in order to do this, we need to have a lot of tools in order to monitor the quality of data or estimate the quality of data or whatever, and then performance tool to monitor this one, right? And then all the process is to change it. So here is just a high-level abstraction, but when we go into the implementation, it also depends on your framework, because sometimes you are not able to enter inside the workflow. If you consider it's just black box, then you just do outside. But if you are working inside the workflow, then you're able to change, even inside here, right? And then the underlying is about the result. Okay, so this is the approach with a couple of technical, myths that we developed so far. I want to show some initial results. Well, in particular, actually, I want to show two master theses working in Alto, so to see that how we work, how we transfer and apply the idea into, initial work with master student yet, because I want to do it more with business students and so on, and collaboration with FCAI. So I don't talk about the paper that we work with Chicago, but we're still working on journal paper. But I want to talk about two master theses here to show you the way how we are working here. So first of all, one of the first thing is with retail forecasting, actually Sellforte is a startup company just sit over there, 5 minutes from here. But I think now they get why a lot of customers, the principle that how can they do the marketing, the advertisement for marketing, where to put the market, for example, where to sell chicken or whatever, I don't know, it's a lot of things, right? So they have a lot of data like this in different city locations, and they want to predict. So follow the approach I mentioned before. We ask the student and the guy there, okay, what are the important metrics, right, for your application? So for them, for example, okay, the data size, the hours work, time, cost, for example, is some important metrics. They use this one to evaluate the accuracy of the marketing model, the model of predicting the markets and something. Then pipeline, right? So the thing that they basically have a basic principle that initially they just have a typical pipeline. So they get the data, then they just run, the pipeline to do the regression and forecasting, right? And then has to get a result. But then when we start to introduce the concept, they start to think about it. So first of all, they start to thinking about, can I have some kind of new activity, new task in the pipeline that you start to do like cleanse the data, or you can have some task like, for example, to change, to have the data running with different, kind of result and changing it. So basically, the first thing is try to change the way you design the machine learning pipeline. But in principle, this kind of new task actually can automatically add, right? If we do in the right way, we have a tool, then we can automatically add. So if you submit a typical pipeline, right, like what we see before, if we have the right tool, we can modify the pipeline with the new task. I think this is a very interesting task that we can do in terms of optimization of the machine learning. But okay, in this context, students just, and the guy company just do it by themselves. So, and then now give to you that why the end-to-end is actually much more difficult than just have a model and running, right? So for example, if you see here the principle that if you see the user, then they have model in S3, then when they run the model, the model running in a lot of machines, can be hundreds of machines or whatever here. And then, in order to guarantee about quality of analysis and control whatever, we need to add some other component. So first of all, that's why we develop a new component to allow us to communicate the quality, the quality of the model or whatever, go back to the data scientist so they can see it. So the black box is here. We have a lot of monitoring, metrics, and user-defined data, and so on and so forth inside this one. So I give you some example, like for example, they start to develop, custom metrics. So the system will give you a lot of metrics, but you can develop a high-level function to determine what is the metric, in your view. For example, this is the cost metric, and the model, the accuracy of the model have to log. And then they can develop action. So for example, the action here developed by the guy working on a machine learning system, so that they understand, okay, if the metric, the quality like this, like that, what kind of action they should do. So I don't know go into the logic behind it, because why they decide to do this is a different story. But here is the way, the mechanism to allow us to how say, to develop a couple of customized functions or whatever there and put into the system so that we can really do the control, right, at runtime. So at the end, for example, they run a lot in Amazon and get something with different performance or whatever. But here, the summary, for example, in some case, they would like to accept, like 13% lower accuracy. But for them, it's like 44% of time shorter, right? So as long as they say this number is still okay, then they try to do this kind of thing because they can reduce a lot of money and time. And the technique to do this is, of course, monitor, the matrix, and then based on the matrix, train the machine learning pipeline. So here, I'm not going to argue the number or whatever because this is very much depend on application and domain. But I want to say that the principle that we have to think that the guy in such a machine learning production, they have different, quality of analysis depend on different situations. And our job is mean that if we understand the model very well, we have the platform or whatever, we need to provide a mechanism for them so that they can define the function or whatever, then the system can optimize it. Right? So if you want to achieve this, you also need to work, with, for example, with the application domain as well. But the application domain guy, for example, they don't know about this kind of low-level stuff, right? So how can we help them to work on this? Another example is another master thesis. I think we submit this month or next month. Almost done. We do with Solibri, right? Also, the company here is how can we do the machine learning classification for building information modeling. So the thing that they have, for example, different kind of models. Like in terms of building, you can have 3D, you can have numeric, you can have text. So actually, it's different type of data. They need to go into different process to extract the feature and so on, then put into the training, and then put into prediction. So we all know that this kind of phases cost a lot of time. So then the similar mechanism that we try to apply the principle of quality of analysis into this one. So the system, end-to-end system, is not just machine learning, but you see that if from the tool they can extract the data into file, then send the data into data storage, and when the data go into the storage, it automatically inform the data collection, which triggers a different process to extract the feature and so on automatically. Then when they have the extracted information, it triggers the machine learning automatically. So this is a whole end-to-end, right? A whole end-to-end pipeline with different phases glued together. Run it. And then give you some example. I don't go into the the number here because it needs a lot of time to explain it. But the principle that you see that we try with different data set and then different machine learning, machine configuration, for example, Amazon and local with GPU and without GPU or whatever. But the goal is the same. It means first, can we understand what are the important quantity of analysis, the matrix, and their relationship? So do a lot of experiment to understand what are the important matrix and relationship. First of all, accuracy is important, right? Data collection time is also very important. Machine learning time important. But object, the object count inside the data set also very important, for example. And then the students do a lot of experiment to see, the relationship between the machine learning time, the data collection time, the object, for example, here is similar. When you have an object, 3D object, you can decide how to extract the data. Very fine grain or very, high grain. Yeah? If you do very fine grain, it means you generate a lot of data. And then the accuracy is higher, but then it's cost a lot of time. So the principle here is the same. It means that in this kind of machine learning application, people need to understand a very important matrix, and they know how to extract this kind of matrix. And our job is, can we, for example, support them to how to say, to monitor the matrix, to combine different matrices and do certain action. So, so this is another example to show that the way how we try to understand what is quantitative analysis and then how can we apply the principle of elasticity. I mean, the thing here, is, as you see, is just initial research, because one of the first things, to apply quantitative analysis and principle of elasticity means you need to understand the matrix, right? The dimension. What kind of, how say, elastic object where you can manipulate, we can change it. So first of all, if you have a 3D shape of a sofa, extracting the data can be elastic object, because you can have different way to extract the data. You can extract only the dimension with a very high grain or very fine grain. You can extract the dimension from 3D, but also the text and the command and something as well. So it's a very important to know which matrix and to know which type of elastic object that we can deal with. Yeah. So to show you, the concept, and then also some initial results that make us to believe that, or at least I believe, so I try to convince students and so on, that this is a good direction where we can really work with machine learning people, try to understand the matrix, the requirement for the machine learning system and so on, so that we can develop what I call R3, robustness, reliability, resilience, and elasticity for the machine learning. So I think one of the first things we need to work is the matrix, right? Can we have a conceptual framework and how to define quantitative analysis? I mean, we know there's a lot of matrices are very specific, right? But still, from the machine learning viewpoint, software system viewpoint, for us it's important to allow people a mechanism to define it, right? Because at the end, you don't know, what is the data about, what is the matrix about. But how can we approach this? Right. So I think need to sit together and think the way. And then if we're able to define this in the right way, we can implement into the framework of programming language and something like this. Think about quantitative analysis as a contract. So we have working a lot in service contract and data contract for a long time. Now, if a machine learning, can we have a contract? So I know that a couple of systems now, they have like serving, right? A serving platform. You have a model, you deploy model into the platform, then you just feed the data, then the model run. If you develop a model and offer the model as a service, running in the platform, what is the contract between you and the platform? I think the quantitative analysis could be a right way to establish a contract, because at the end, you have very good model, but if the infrastructure have not guaranteed, the computing resource have not guaranteed, checking, wrong data or whatever, right? Data out of distribution and so on, going to your model. Your model will create some bad result, and who are going to take the responsibility for this? And monitoring is very important. And here the tricky part is certain metrics we are not able to monitor, right? Only the guy in the domain who really understand it. So what is the right mechanism? I mean, remember, like when we work in workflow, we also have a concept of human in the loop where the metrics have to be defined by the scientist. So pop up a dialogue and the scientist look at the picture and say the metric like this. We have no mechanism, way to determine the metrics automatically. We only provide a mechanism for people to interact with the system to define the metrics. The application specific resource example probably more on the software system rather than in the interesting of the machine learning people. But still, we need to think about that. Nowadays machine learning production, they are leverage cloud and edge, and then most of people running with container, Kubernetes, and something like this. So if we want to make it successful, we need to, even if you develop the model, you need to test with container, Kubernetes, or whatever. You cannot just run in a typical machine and make assumption that people will be able to deploy it. Then quantitative analysis aware and machine learning flow coordination, right? So as we see, we can coordinate different phases, and inside each phase we might able to manipulate different tasks and something like this. So how can we develop the right tool for this? So now there are a couple of companies and and system, they already develop a tool allow you to coordinate different phase. Trigger the thing automatically like what we also did in student thesis, but it doesn't mean that they are able to deal with the quantity across multiple phases, because that's the most important thing. If the data is bad, why should you go to the next phase? Very difficult. And Elastic machine learning model serving platform, I think it could be very interesting. I think it's especially when people are talking a lot more about ensemble and federated machine learning, right? It means that, how can you have multiple model or whatever, you combine them together, but you solve it in an Elastic way. I think it could be interesting topic, way to go. And of course, from the system viewpoint, for us, it's also important to utilize machine learning to understand quantitative analysis, right? Because it's so complex, so can we understand the quantitative analysis? And adaptation and optimization, changing the system, changing the model or whatever, at runtime is also a very hard job from the software system viewpoint. Yeah. So to conclude, I think that quantitative analysis can be very useful as a contract. Contract here is abstraction anyway, way for us to achieve robustness and reliability, resilience, or elasticity. Achieve, I don't know, but I think at least to guarantee, right? So if the customer, the user say this and that, what I want, even a scientist who run, for example, training the model, he has a certain budget, certain time, certain, constraint. Can we do this? I'm thinking like, for example, some selected scenario like training optimization, runtime machine model serving, or some other thing related to, for example, can we detect like out of distribution detection and optimization could be a good scenario. And elasticity engineering could be a good technique to deal with that, because the system is too complex. So sometimes if you just change, a certain type of object, even very high level, like change the parameter of the machine learning model, even without knowing what happened inside the machine learning, you already can make a substantial improvement, right? Only when you have everything, for example, you have the machine learning model, you have the infrastructure, you have everything, then you can change everything in very detail. But usually in the end-to-end system, we are able to change only a few phases. And if you look at the layer, you're also able to change only a few layers, right? So how to do with that? But this idea won't work if we don't have a real machine learning and something like that. To be honest, we have data. We know machine learning, so we write, let's say, hello world machine learning model, and we run with Kubernetes and container or whatever. But the hello world machine learning is, is not really, really good for us to really, if we want to publish, in a top place and something like this. So I took this opportunity when he asked me to give a talk, and because I would like to have better collaboration, where maybe we can share some machine learning model, some way to develop this idea along this line. Yeah. Thank you very much.
So thanks a lot for the inspiring talk. So unfortunately, you didn't leave us very much time for discussion, but we have time for a couple of quick questions.
So if there are no questions, so thank you. It was really interesting, especially for my research, and I think I would have a good test case for you in the future. So we are just starting a collaboration or a research project funded by Connect Range, the company. They gave a donation where we are doing machine learning for detecting the humans in the industry areas, and also doing more cost-efficient kind of like location of the cranes. So I think there might be really interesting collaboration in the future. So we're just now starting, but maybe in the fall, because we are also taking the whole path, so collecting the data and checking it, and then doing the machine learning.
Even when you detect the people in the area, you also have very different qualities, because sometimes, for example, in emergency situation, you would never spend a lot of time to do this. You just try to weekly count, maybe 70% accuracy, that's enough.
And in the future, the hope is, of course, that this will be real time and everything.
Right.
So I think we feel the whole path that we also explain.
Yeah. So, particular thanks for kind of giving the kind of tentative talk on conceptual things that you are developing now, right?
Yeah.
So people seldom are kind of too seldom are courageous enough to do that, right? But so what? Because it's a very different field in what I work, so I'd like to get a kind of some kind of handle on what would be a result like in your field, right? In a paper. So what makes it a paper? Is it the conceptual framework, or is it the system, or is it some kind of software elements that actually then implement the resilience?
It depends. First of all, if you are just thinking about quality of analysis, contract model, you can go more on, for example, the service and something. So this like artifact, like similar like what we did, like you can specify what are the elements inside the contract and what are the model of the contract. So the model of contract is, how to say, it's like a schema or whatever. But if people accept it, then they take it, they implement in their framework, right? So it's a like artifact, but it's not really a whole software system, but it's more on, let's say, from the contract viewable model. This is one way. The other way that, for example, the typical we are doing is mean that we actually provide a software system with some technique. So for example, if I develop some monitoring for quality of analysis and change like this, it means I need to have a framework. It's similar like the student work, but in more generous way. It means you define the function, follow my convention. Then when you run your system, then my system will be able to monitor, to give you the metric and to control it. Right? So this is also another work. And another work, it means that actually like you do experimental analysis. It means you run a lot of experiments and you report the things. So I think it's all depends on the flavor, right. on the flavor. So some of us also work on, for example, the elasticity control. It means it's basically algorithm, but we need to implement. So for my team, everything have to come up with the prototype that's run in, I would say, large-scale system in the sense of, we have to run in the real cloud, real edge, and usually if you run it like 10 machines or 20 machines, people will say, no, it's not real, So it means that the real software, but also the real system is important.
Thanks, this helps think about it. When you said control in the second out of the three, if I understood correctly, so would that be automatic control in some way or manual?
I think there's two different things. This means what at the moment that most of the things is mean automatically control, but the question is the trigger. The trigger is mean the decision maker is it's intelligent or stupid. It's another story. So for example, in some case, the situation is probably straightforward, right? You just have a set of rules. So you monitor the metrics, very complex and so on. But then you fit into a set of rules. Then that rule will trigger the control. So it's automatically, but the rules might not really super intelligent. And other situation is we have to develop kind of machine learning algorithm, right, to predict this, so replace the rule to do something better. So in the system viewport, there's a lot of technique to allow you to define the rules. And then you can control to deploy the machine, to control, for example, the parameter or whatever. So it's not very intelligent. But there are also a set of people working a lot on intelligent algorithm. Actually, they use machine learning and whatever to make a decision. But the control usually is automatically. Only when you run in very, very long. So we have a concept like we developed like in simulation a long time ago. Only when you run the pipeline for a long time. For example, think about like if you have a simulation, different phase 1, phase 2, phase 3. Then you run like 100 machines in 1 week. Then you extract the result, you go into another phase, another simulation, final grain. Then it makes sense to allow people to control. Because if you spend like 10 minutes or 20 minutes as a scientist, you probably make a better decision than to have a software. And that 20 minutes, it's nothing if you compare with if you run into the next phase, it's got you another week with hundreds or thousands CPU. So it depends on the cost and also depends on the data. I think, but most of the situation at the moment we want to do is automatically.
Thanks a lot. I think we are over time already, so we need to end now. And you are available at Aalto if people want to talk.
Yeah, thank you. Yeah, sorry that I took all the questions.